We've all experienced failure of a web-connected component in our home automation setup due to API failure or some other internet-related outage. So today what I want to do is show you how I'm bringing in my weather data directly to Home Assistant using a Raspberry Pi, an SDR receiver, and MQTT. This is a longer video, but I hope you'll watch to the end so I show you how I get all the way from my weather station into a Grafana graph. So let's get started. All right, for this project, you're going to need a few things to get started here. You're going to need a Raspberry Pi of some sort. And I have a Raspberry Pi 4 here. And then you're going to need an SDR kind of receiver. This is a NESDR Mini 2 Plus. It's a frequency compensated crystal oscillator or temperature compensated crystal oscillator, which means it won't drift. So you need to make sure you have one of those. You're gonna need a case to put it in if you choose to do that. I just happened to buy the Cana kit that has the case with it. And then also you're gonna need a decent power supply. A decent power supply is to help power that USB dongle. If you don't have a decent power supply, then trying to power the USB dongle is not gonna work very well. This one outputs about 3.5 amps, so it's pretty decent powered. It's also probably filtered, so make sure you have a good power supply. And then finally, you need some sort of SD card. This one came with a 32 gig EVO Samsung card, so you need that to put your operating system and everything else on. All right, those are the parts lists. Okay, so I'm going to assume that you have installed Raspbian Buster on your Raspberry Pi and that it's up and running and you're able to SSH to it. Now you can do this through a straight regular HDMI output to your monitor or whatever you want to do, but you need to have access to the device, obviously. So that's the assumption here. So we're going to start with installation of a couple of tools we need. So first things first, let's get RTL SDR installed. So I'm going to make a directory called SDR. And I'm going to change to that directory cd SDR, and then I want to make sure that I have all my latest packages on my Raspberry Pi, so I'm going to do an update. And it's not actually getting my packages, what it's doing is making sure I have all of the locations for all the files and everything, so all my package locations and everything are up to date. So that's what we're doing now. Let's go ahead and install these necessary packages. apt-get install. We'll get cmake libusb-1.0-0-developer version, the dev version, so we can build against the dev version, and then build essential. And it's asking me if I want to install all these. The answer is yes. So now we'll download everything and we'll get it installed. Okay, so all that is installed. So the next thing we're going to do is we are going to clone the RTL SDR packages. So because we installed Git, we can use Git. So clone, and then the location is Git, or the protocol is Git, and the location is git.osmocom.org rtl-sdr.git. And we're grabbing all the packages. We're cloning that repo. All right, so now what we want to do is change to the rtl-sdr directory where we just downloaded everything to. And we're going to make a directory called build. And we're going to move to that directory. So now we will make the file, or make the executable for RTL SDR. We're going to send it some flags concerning the UDEV rules and the kernel driver. These are super important to do, or it's not going to work correctly. All right, so deinstall -d install udev rules, and -d detach kernel driver. So let's go ahead and compile and make these this package, this executable. And that was quick. We're done with that. Now we're gonna actually, what we did before was we actually configured. Now we're gonna actually make it. And now we're building all the objects. That's complete. So now we are going to make install. We'll use sudo for that so it can put it in the correct directories. And we're going to run ld-config as well. All right. So that is the installation of the RTL SDR binary, executable, whatever you want to call it. So now what we're going to do is we're going to install the RTL 433 package. And that's, again, the thing that's going to do the decoding for us whenever we receive a signal from our weather station or anything else. There's probably 180 different things you can decode from with this. So first things first, we are going to go back to our SDR directory. And we're going to clone a repo from GitHub. And this is the author of RTL 433, Murbanin. Could be saying that wrong. But here we go, grabbing the GitHub files. And same thing we did before, we're going to go into the RTL 433 directory this time. And we're going to make a directory called build. And we are going to change to that directory. And we are going to go ahead and do our cmake this way. But only if we spell build right. Compiling. That's done. All right, so again, we'll do a make here. All right, that's done. It took a couple of minutes because it's it's compiling objects or support for every single type of device that it can decode data for. And there's quite a lot of them. So it took a couple of minutes to do that. All right, now that it's built, let's go ahead and install it. So again, sudo make install. And ready to go. Now, if everything worked out the way it should when we installed this package and the RTL SDR package, we should be able to type RTL_433 and start listening for activity on that frequency. And I'm going to use a frequency of 915 megahertz. The 915 megahertz is where my weather station transmits. It's an ISM frequency. And so let's give it a command and see what happens. So RTL 433, and the flag for frequency is -f or lowercase f, and 915M for the frequency. And now you can see that it has found my micro tuner. The sample rate is whatever that is, something 1 million hertz. And then the tuner is set to auto gain and a frequency of 915 megahertz. And we will wait and see if we hear any traffic on here. Here's our first bit of traffic. What we're seeing is a fine offset WH25. That is actually a little pressure temperature sensor that I have that's in the building here. It's set to display in Celsius. So what that tells me is this is all working like it's supposed to. So let me do a quick little change here, and we'll change the flag to show in Fahrenheit since I'm in the US. I want to do a -C, I believe it is, customary. And what that's going to do is it's going to start decoding and showing the output in Fahrenheit instead of in Celsius. And you can see it's done that here. We have still the fine offset WH25, and a temperature of 74.5 degrees Fahrenheit. And then our pressure is going to be in inches of mercury instead of hectopascals. So I know that this transmits every 1 minute and 4 seconds, so I'll get an update as it goes along here. But what it also tells me is that my Raspberry Pi is working, my SDR, my little USB SDR is working, and I have at least a decent, well, at least a working antenna. So now what I can do is I can start sending data to my next step, which will be the MQTT server. So also you'll notice here that I just saw a bunch of traffic from, it looks like a power meter. I don't know whose power meter that is. It's probably mine. I know we have smart meters here in the US and in my neighborhood. So it's quite likely that this is my meter. I know that there's a solar panel set up on the house next door with 2 meters that are in the same proximity as my meter. So it's very possible I'm hearing their meter as well. But the point is you're seeing traffic here, which is a good sign. Next up, what we're going to do is we're going to configure Home Assistant, MQTT, so that we can take the data from RTL and put it into Home Assistant. So let's get started on that. All right, now that we have the RTL 433 package installed on the Raspberry Pi, what we're going to do next is we're going to come over to Home Assistant and we're going to configure the MQTT server to be ready to listen to packets coming in from the Raspberry Pi. So let's start by going to Supervisor, and then we'll go to Add-on Store, and I'm going to search for MQTT. And you get a couple of options here. You'll get the official add-on and you'll get the community add-on. I always lean towards the official add-ons rather than the community if one exists, so I don't have an issue if the community add-on goes away. Also, in this community add-on, you'll notice that this is deprecated, which means it's basically going to go away at some point. So again, lean towards the official when you can. I've installed the official Mosquito Broker already, and in configuration, it's all default. So there's nothing here. You can put login, username, and password pairs here, but what we're going to do is we're going to use Home Assistant's users to be able to authenticate the MQTT server. All right, so for that, let's go back over to our configuration. We'll go down to users. I've got a few test users in here, but I'll show you how I create a user pair, user password pair. So the name is going to be MQTT test 3 because I have a couple already. So MQTT test 3 will be the user and the password APC123. Don't ever use ABC123 in production, ever, ever, ever. In fact, never do that, ever. That's bad. I'm going to use it here for testing, and then I'll be deleting this after I'm done with the video filming, so no issues there. So we'll create that. So now we have an MQTT test 3 user. So that essentially sets up MQTT to be ready to go on Home Assistant. And what I'm going to do now is go back over to integrations, go to MQTT, and I'm going to get ready to listen to a topic. I have nothing on my network that's sending me any MQTT, blah, 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 right now. So I need to do some stuff over on the Pi so that it will send some information over Home Assistant. So for that, let's go over to our terminal window and let's take a look at what we have here. Let's clear all the junk off the screen. All right, so what we're going to do is we're going to create a command line string that'll send MQTT data from my weather station and anything else actually that this RTL 433 hears over to Home Assistant. So for that, we've already installed the 433 binary. We're going to give it a flag of -C customary that gives us the Fahrenheit and the inches of mercury pressure reading. And then we're going to go ahead and give it the frequency. We need a frequency, so $lowercase f 915 megahertz, which is where my weather station happens to transmit. And then I'm going to give it a flag of -f, which tells RTL 433 what kind of output we're going to want. And for that output, we're going to want MQTT. So we're going to create a big MQTT string here. And this is the host name of my Home Assistant instance. Port 1883 is one of the MQTT listening ports. And because we are required to do username authentication on that integrated MQTT server, we will have to send it this username and password we created just a minute ago. You can go without using username and password, but you have to configure access control list within the MQTT configuration. I haven't done that, so I'm just going to go straight up with a username password. It's the easy route versus the ACLs. If you have devices that are going to send to this MQTT server that don't have any authentication, you're going to have to set up access control list for it to work. So anyway, there's my user. It's going to be, what do we call it? MQTT test 3. And then comma, and then the password, pass, is going to be ABC123. And then for what we're sending, we're going to be sending events, which are basically what the topic's going to be for us to listen on the other side. So my events are going to be formatted this way. The name of the program, and really, as far as this first part goes, I think you can use anything you want. I'm just going to stick with RTL 433, and then I'm going to give a flag here that gives me the model of the device that I'm getting events from, and then I will also give it the ID number of the events. Oops, how do we do that? Let's see what we did here. So test 3, somehow I deleted everything. So pass equals ABC123, and then events equal RTL underscore 433, and then a bracket slash model, and then another close bracket, another open bracket slash ID, close bracket, and then closing quotes. Let's go ahead and hit enter and just cross our fingers and see what happens. Okay, good. All right, so what you're seeing here is that we've got MQTT connected, and our MQTT connection is established. So you won't see any more output on this screen. All the output is now being fed over to our MQTT server at this IP address and port using this username and password. So let's go back over to the browser and let's take a look and see if we're getting anything into our MQTT server. So if you remember, we used RTL underscore 433 slash model slash ID number. And we get the model and the ID from the MQTT or from the weather station or other devices. Every device sends that information over. So we can distribute, or we can pull it out and then build our sensors off of that. But I want to see everything that's coming into my RTL underscore 433 events. So I'm going to do a RTL underscore 433 slash hashtag. The hashtag basically says, send me everything that starts with RTL 433 that's coming into the MQTT server, and we'll start listening. And right away you can start to see some stuff. I find it interesting that I can just put a radio out there and start listening to things. I don't know what this is. I'm assuming a neighbor's security system, basically giving me the switch states of everything in the house or in this security box or whatever it is. I don't know what it is specifically. So we go down and we look through and we see, it looks like we have a power meter, more power meter stuff, and more power meter stuff. And then what we have here is a WH25, which is my temperature and pressure sensor. That's a little standalone device I have here in the house. And it's giving me temperature, humidity, pressure in inches of mercury, and then some other information. So keep in mind that this is all coming to us in JSON, because RTL 433, when it sends an MQTT packet, it formats it in JSON, and then the MQTT server picks it up and decodes it here. So what it tells us, number one, is that our Raspberry Pi is working. We're receiving data on the SDR, the little receiver. RTL 433 is processing and decoding that data. It's feeding it out to the MQTT server, and our MQTT server in Home Assistant is picking all of that information up. So now we need to figure out what we're going to do with this. You've got to create some sensors now in order for Home Assistant to do something with this. So let's go over to our terminal, and I'm going to take you through some of the sensors that I've already created. I've created one for temperature, humidity, RSSI, rain, wind speed, wind direction, all the stuff you would typically get from a weather station. And so you can see how we do this here. The platform is MQTT. That tells Home Assistant to look at the MQTT server for its information. The state topic is what we talked about before. This is an event, RTL 433 underscore model, or I'm sorry, slash model slash ID number. When you're looking at your feed, you have to determine what you're looking at, and you have to create the sensor, the state topic, based on what you're looking at. So I know that this is that little, well, actually this is my backyard weather station. So I know that that's what that is. So I created a sensor to be able to view the temperature data from that. So I have a name of WH65B temperature, and that's the sensor package that's in the weather station. My unit of measurements, Fahrenheit. Force update is true. Force update on these sensors means that even if the data is the same, if it receives a value over MQTT and there's no change in the data, it's still going to register that. And it does that. I do that because I want to graph this over time. And if I don't put true, and let's say the temperature stays at 70 degrees or 75 degrees for 3 or 4 hours, then I'm going to have nothing on my graph for that 3 or 4 hours. And it'll look to me like something has happened. It's not getting data. So I set this a force update true, so I always get a data point regardless of whether it's the same data as before. And then the value template is the money template here. So what it's doing is it's looking at the state topic. And if we go back over here, you'll see this packet has a temperature underscore F. Now keep in mind, I'm looking at this, this is a little bit different event or state topic. It's the WH25216. It's the same principle. You're going to get a packet, you're going to get this state topic, you're going to get the information here. And so what I'm doing with the value template is I'm taking that value of temperature F out of this sensor or out of this packet, and then what's happening is it's being decoded into an actual value. And what this is going to give me is the actual temperature Fahrenheit from this particular state topic. So every time that comes in from my weather station, it's going to read that, it's going to create this value temperature template, and it's going to put it somewhere. You know, in Home Assistant, you've got your history, ability to store things in history. It'll do that. If you're displaying it on a dashboard, it'll display it on a dashboard. In my case, I'm sending it to an InfluxDB through my Home Assistant, and then I'm going to be graphing that on a Grafana visualization. So it's the same thing for all of these. Again, platform is MQTT. Here is the outdoor weather station. This time I'm looking at humidity. The name can be anything you want it to be. And if you look at developer tools, you can actually search for these. And of course, developer tools is over here on the left-hand side. So you come down here to developer tools, click that, and then you get this screen here. And I'm going to click on, or I'm going to search for WH25. I'm going to do 25 because that's what I actually am getting from my feed right now. So you can see if I go into my terminal and I look for that WH25 sensor, so you can see here that I'm looking at this WH25216 right in this area. And my sensors are WH25 temp F. If we come over here to developer tools, we'll see this WH25 temp F. And what it's doing with the name is it's actually putting underscores, lowercasing everything, putting underscores. So my WH25 underscore temp underscore F is the same thing as my WH25 temp F, they just put underscores and lowercase everything. So whatever you name this is what your sensor name is going to be. So let's go back up a little bit. I have a couple of caveats to talk about. So in these weather stations, at least the one I have, I don't get feels like, or heat index, and I don't get pressure. Those are all in the actual head unit or the display unit. The display unit of the WS2902 doesn't transmit anything. All it does is send stuff out to the various services like Weather Underground, Ambient Weather, some of those, right? So I can't display those natively from the data stream I'm getting from my weather station. So we had to do some work on that. My brother, who's smarter than I am, he actually worked with me on this, and we were able to build this value template, which is massively long, but it's the heat index calculation that we get from these other sensors. We take the temperature and humidity, and we do a lot of calculations on it. It brings back our heat index. So it is possible to take sensor data from your weather station and actually make more sensor data from it. So when you create, or after you've done the work to create the sensors, you want to definitely make sure that you go back over to your configuration, and you're going to do server controls. Go to server controls here, click on check configuration, and make sure your configuration is valid for all the sensors you created, and then restart Home Assistant. Now that we have data flowing in from our Raspberry Pi through our MQTT server into our sensors in Home Assistant, it's time to do something useful with them. So let me create a couple of graphs just to plot the data. So whenever you create a sensor in Home Assistant, and assuming you have InfluxDB set up and Grafana set up, and I've got other videos that I show that in, you should be able to just start taking the data from the InfluxDB and putting it in Grafana. It should automatically be going over there unless you filtered that out. So let's go to Grafana, and I'm going to create a new dashboard. So dashboards, manage, and new dashboard. And it first wants me to add a new panel, which I will do. And this is going to be a graph panel, because what I'm going to plot is I'm going to plot the temperatures that I'm getting from the little sensor box that we're using that's inside my house. And that's the WH25 topic that we talked about earlier. All right, so nothing on the panel right now. And when you go into this, you want to make sure you're using the correct data source. Correction up here, correct data source. So I'm using my default data source. I'll just keep it at that. That's where all my Home Assistant information is going into. And then I'm going to select a measurement. And these are all the measurements that are in the Influx database that the Influx database knows about in that default database. If you choose a different database, it might have different measurements in it, but these are all the ones that it knows about. And if you remember, if we go back and look at our sensor setup here, you'll notice that we specified unit of measurement. That's how Grafana knows what kind of measurement it is. So we'll select Fahrenheit, because I know that's what we're getting. I know that Fahrenheit's all the way at the bottom here. So I'm going to choose degrees Fahrenheit. When you do that, first of all, you're going to get everything that has a degree Fahrenheit reading in your whole database, which we don't want. We're going to further filter this using a where clause or a where statement, and I have a couple of choices. I can either use a domain, which I hardly ever do, or I use entity ID. And the entity ID is going to be filtered automatically by Grafana for anything that contains this degrees Fahrenheit measurement. So if I select that tag value, all of these particular entity IDs have a Fahrenheit measurement. But I know that I created the WH25_temp_F sensor, and that's what I want to measure, or what I want to select for my measurement. And you can see right away that we get data in this graph. And let's name this. You can see right here it says f.mean. That's because it's taking this and this and creating the default legend for that. So I'm just going to call this Fahrenheit. You could leave it blank, I guess, if you want to just leave it this way, and it'll change that to Fahrenheit. And the reason I do Fahrenheit here is I'm just going to say indoor temperature. And when I select indoor temperature, I will know that this line is Fahrenheit. You could, if you had humidity or something else plotted on here, you could also just change this title to indoor and then your two different graph lines would be different humidity Fahrenheit, and it would be specified via this legend. That's all subjective. However you want to name it, however you want to put it together, is up to you. We can do a bunch of things with this. The first thing I want to point out is you can see how often this is updating. It should be 1 minute and 4 seconds for that device. It'll send me an update through MQTT. If you remember what I said earlier about the force, and I'll show you here. If we set force update to true, then all of these spots right here are going to come across as points on the graph. If you didn't set force update to true, that sensor would only update during a change. So you would only see a dot here, a dot here, a dot here, and a few over here. You wouldn't see all this in between. That's why if you're graphing this, it's important to set that to force update true. If you're just using a dashboard or something where you just want to display the latest temperature, you probably don't want to use force update, because what you're doing with force update, you're also creating entries in your database. And I'm doing 1 minute 4 seconds for this. My weather station updates every 16 seconds. And so I am going to keep all of the plots or all of the data points. But if I'm just displaying it on a dashboard and I just want to know what the current temperature is, and if it hasn't changed, it's still the current temperature, right? That way I'm not filling up my database with useless information. But I'll keep it force true for plotting it. Over here on the side, a bunch of different things you can do. Bars, you can change this to bars. You can do your line widths. You can do a area fill. You could fill it if you wanted to. Area filling works with a line. My fill gradient would be something like that. And what else do we have here? If you want to connect all the points together, then you would come down here, and rather than having a null value, you would do connected, and it's going to generate a line. That's where the fill comes in. So you could turn the fill off. You could turn the fill on, make it less visible. The gradient makes a difference. Again, these are all just personal preference, how you want your graph to look. You can also turn on your points whenever you have the fill on, and I set my point radius to about 0.5. This way, if I have a line, a connected line, I still want to see how often the thing is updating. And this tells me whether or not I have blanks or gaps in my data by looking at the points like this visually quickly. What else can we do? We can do legends. We can do where's it at here? We can show the values, min and max. So minimum was 72, maximum was 73. You can do an average. You can do current. You can set this as a table, so it then makes it in table format. You can put the table on the right-hand side. So if you had a whole bunch of different sensors on one graph or one visualization, you could put those and then make a table out of them. I don't necessarily need to do that, so I don't show any of that. You can show the legend again if you want to. We'll take it as table to the right and take off current. So then you just get this label for what this is. If you set the temperature here to temperature Fahrenheit, indoor temperature Fahrenheit, you can get rid of that label completely. Again, I'm just showing you a bunch of different options you can use for this. If you want to look at the query, the way this query actually looks, you can click on Query Editor, and now this is the actual influx query. Select mean value from temperature Fahrenheit, where the entity ID is this, and the time filter, which is this time filter grouped by the interval, and then the fill for this is null. We're not filling any values in between the updates, but it's very simple, at least to me, right? So I'm used to using MySQL and SQL queries. This is influx query. It's a little different, but pretty close. So that's what the query looks like if you were to write it out. All right, so I'm pretty sure that covers getting the data all the way from the Raspberry Pi through to the MQTT server into Home Assistant, and then into some sort of graph or useful information. You can also go in and you can add this same stuff now that you have a sensor. If you want to go into your whatever favorite dashboard you have, if you have displays around your house or something like that, you can do this. So I have currently, this is my current outdoor weather station, and that's coming through the Ambient API. Once I'm comfortable with where my weather station signal is and the data I'm getting, I will most likely replace this, or at least add another block next to it, so that I can compare the two and make sure that they're doing what they're supposed to. Other than that, I think that's all we have for today. I appreciate you sticking through to the end of the video. I know it's a longer one, but there's a lot of steps to get this working. And if you can calculate things like the heat index, if you can calculate the pressure, which there is actually a pressure calculation formula as well, you can create a sensor similar to this one for pressure, then you have all your data to yourself. If you lose internet connection, or you lose connection to the API, or the API goes down, or for whatever reason API access is discontinued, you still have access to your weather station data. You can still put it in your dashboards, you can plot it, you can store it. And that's what I was going for. If you have any questions, leave those down below in the comment section. Make sure you hit the subscribe button, hit that bell icon in case you want to be notified of new videos when I make them. And if you feel like you want to help support me in this endeavor, throw some bucks in my Ko-fi account, or become a patron on Patreon, and I'll link those down below here in just in a minute to the description. So thanks for watching, and we'll see you on the next video.